This video is all about isomers. So hopefully before you've watched this video, you have already learned about alkanes and alkenes and are able to draw their structures and name them. And if you're not able to do that, I'd recommend that you go away and you do that first, and then you come back to this video. So let's have a think about alkanes and alkenes. So I'm not going to go into a lot of detail here because you should have that prior knowledge before this video. But alkanes and alkenes are both types of hydrocarbons. So hydrocarbons are compounds made up of hydrogen and carbon only. And we know that for the purposes of GCSE, you need to know about alkanes and alkenes. So have a think about the similarities and differences. You might want to pause this video here and then have a think about it. Okay, so let's have a look. The main differences we've got, main similarity, is they are hydrocarbons. That is what they have in common. Our differences are that alkanes have only carbon-carbon single bonds, and alkenes have at least one carbon-carbon double bond. Alkanes are saturated. We use that term to mean that they have carbon-carbon single bonds, and that essentially it means that they are full up. They have the maximum number of single bonds that they can have, whereas alkenes are unsaturated. Because they've got that double bond, it appears like they're not full up. They have at least one carbon-carbon double bond. So in exams, if they ask you, what does the term saturated mean? You would just say it contains only carbon-carbon single bonds. What does unsaturated mean? It contains at least one carbon-carbon double bond. Now, beyond GCSE, you might want to talk about things like triple bonds, but for the purposes of GCSE, that is fine. Now, you also need to know their general formulae. So for alkanes, it's CnH2n plus 2, which means that for every carbon atom in their structure, they have double the amount of hydrogens plus 2. And alkenes, their general formula is CnH2n, which means that they contain double the amount of hydrogens than carbons. And finally, we need to know what their names end in. So that's ane if they're an alkane and ene if they are an alkene. So now we're moving on to the theme of this video, which is isomers. So let's have a look at these two structures. So you've got butane on the left, which you should be familiar with, and we're going to use new terminology now. They are, butane is what we call a straight chain molecule. That means that all the carbons are just attached in a row. Now we're introducing you to something slightly different now. If you look at the structure on the right, that is has the same molecular formula, so 4 carbons, 10 hydrogens. However, the atoms are arranged differently. The displayed formula is different. So you can see there that we've taken one of those carbons from the end and popped it on the middle carbon atom. So that means it now has what we call a branch, kind of like a branch of a tree. So we either have straight chain hydrocarbons, like the alkane on the left, or branched hydrocarbons, like the one on the right, where you've got a carbon coming off the main chain. So I've also put a couple of examples at the bottom here for you to look at. You might want to come back and review this part of the video after we talk about what they are. So isomers are molecules which have the same molecular formula but different displayed formulae. So let's look at these two as examples. So we have 6 carbons in both and 14 hydrogens. So they both have the same molecular formula. But if you look at the molecule on the right, it is arranged slightly differently. Instead of having 6 carbons in a row, we now have 5 carbons in a row with 1 carbon coming off of the chain. So now let's go back to that original example that we looked at with butane. I've actually put some 3D structures on the screen for you to have a look. Even though we say they are, the one on the left is straight chain, in reality, if we were to build a 3D model, we will see that it can't exactly be a straight chain exactly as it is on the paper, because that's how we represent it in 2D, but in reality, in 3D, it's a bit more complex than that. You could try to pause this video and build some molecules with some modeling clay and some toothpicks. So we're going to quickly talk about how we might name the hydrocarbon on the right. So you might have seen the name on my previous slide, but let's talk through it. So the first thing you have to do is you have to look for the longest chain. So I can see that there are 3 carbons in a row. 1, 2, 3. That is the longest chain. And we start counting the carbons. So we've got carbon 1, 2, and 3. For this example, it doesn't really matter if you count from here or here. They're the same, but in future, this will become more complex. So on the second carbon, you have a carbon which is just on its own with 3 hydrogens. And this group is what we call a methyl group. If it had 2 carbons, we would call it an ethyl group. So the name is 2 because that methyl group's on the second carbon. Methyl because the group is a methyl group. It's a carbon, 1 carbon on its own with 3 hydrogens. And propane because the backbone, that straight chain, has a continuous chain of only 3 carbon atoms. So now we're going to move on and practice. So I would like you guys to pause this video and try to draw the displayed formula of an isomer of butane, an isomer of pentane, and an isomer of hexane. Now for the last 2, there are more than one example, so you might want to extend yourself by drawing all of them. So the first example was to draw an isomer of butane. So just for ease, I'm going to draw butane in. And then I'm now going to show you what the isomer looks like. So remember we said the name was 2-methyl-propane. So I have to have 3 carbons only in the chain, otherwise it's still butane. So if I just take this carbon and put it on the other side, it remains butane. It's now not an isomer. So I have to put my carbon here. And remember, carbon can only have 4 bonds. So I'm just being super careful to count around each carbon to see that it has 4 bonds. So that's my first one. The second question wanted us to write down draw the isomers of pentane. So I've drawn pentane in for us, so we've got that already. So I know immediately I've got to have only 4 carbons in the chain, because if I just take this carbon here and I bring it on the end, it just will remain pentane. It doesn't change. Doesn't have a different displayed formula. So I know I need to put my branch somewhere. So I'm just going to put it on this second carbon here. Draw my hydrogens in. So that's my second isomer. And now I need to think, how else could I have an isomer of pentane? Well, if I put a carbon on this second carbon here, then this one becomes the end chain, and it's actually the same. So the only other alternative I've got is to put 3 carbons in a row and to have 2 carbons coming off the middle chain. Hydrogens in, remember just to be careful that every carbon has only 4 bonds. Okay, I've put the names in for these molecules. You don't need to know these for GCSE, but again, you could have challenged yourself to try them. So now we're going to do hexane. So with hexane, we now know we must have lots of different ways of doing it, because we don't just have 5 or 4 carbons. We've now got 6, which means we've got many more options. So my first option is nice and simple. I just put 5 carbons in a row. I sped this up a bit and you can now see that I've already started adding some hydrogens, and I put my 6th carbon on the 2nd in the chain. So it only has one branch. That's on the 2nd carbon. Now it doesn't matter if I put it on this carbon or this carbon, they are both 2 carbons in the chain, so they would be the same molecule. Now what I could do is I could again have 5 in a row, and I could now put my chain in the centre on the 3rd carbon. That will now make it different. So I'm just going to pop my hydrogens in, making sure that I'm super careful that every carbon has 4 bonds. Now let's think, are there any other options we could have? So we could have a branch on the 2nd carbon and another carbon, but we can't have 5 and then 2 branches, because then we now have 7 carbons. So we've got to have 4 in a row, and we can have a branch here and a branch here. Now it doesn't matter if both of your branches are pointing upwards or both of your branches are pointing downwards, or one's going up or down. They are exactly the same. It's all about just the position of those carbons. So in here, I'm just adding all my hydrogens, trying not to leave any out. It can be really difficult, but make sure you're checking, especially in an exam situation. Always go back and check. So now we've got those 2 branches. Now we could even have 4 carbons where we have the branches, 2 branches on the same carbon. So I'm going to pop that here just so we can see that one as well. That is another isomer of hexane. So you just have to play around with moving those branches around. So I am going to go ahead and name these just in case you are interested. So this one here is 2,2-dimethyl butane, because I've got 2 methyl groups on the same carbon. This one is 2,3-dimethyl butane, and this one is actually got a backbone of 5 carbon atoms, so that is going to be 3-methyl pentane, and up here we have got it on the 2nd carbon, so 2-methyl pentane. So do play around and practice drawing these isomers. You really, at GCSE, you might be expected to draw some isomers of up to 5 carbon atoms, but that would be stretching it. But it doesn't mean that you couldn't practice bigger molecules, just so when you get the simpler ones, you are able to do it. So now, just to summarise, isomers are when molecules have the same molecular formula but different displayed formulae. And alkanes can be straight chain or they can be branched. And some molecules can have many isomers and others only have 1 or 2.